Alright, so worksheet 2, number 13. The Houston Zoo has a large cylindrical aquarium with a diameter of 30 feet. Water is being added at a constant rate of 4 cubic feet per minute. So what is equal to 4 feet cubed per minute? What variable is that?
dV over dt.
Good, dV dt. That is the rate of change of volume with respect to time. Is it positive or negative? Positive. Why is it positive? Because it's filling up. We're adding it. So again, you got to be careful with signs. They will almost never tell you negative. You'll have to read the problem to get whether it's something's leaking or going down or whatever for a negative. At what rate in feet per minute is the depth of the water changing? So find dH dt when h equals 13. Right, it gives me an equation, pi r squared h. R is 15, so trying to throw us off there. Now, one of the major issues on these problems is when am I allowed to plug values in and when do I need to not plug them in yet? And I would say we have one of each of those for this problem. Before I take a derivative, I can plug one of those in, but I can't plug the other one in. So which one can we plug in and why? Do you know? I got an R and an H. I know R is 15, H is 13. Why can I plug in R?
Because
you're right.
Whenever you do product rule, it's still 15.
Okay, it's not really that reason.
Because the radius is not changing.
The radius is not changing. Okay, so if you have a value that isn't changing, then it's not a variable, right? The word vary, it doesn't vary. So R in this problem anyway is not a variable. R is a constant for this problem. So since R is a constant, again, for this problem, I can go ahead and fill in 15. H is changing, H is varying, H is a variable, so I better not change H. So V equals pi times 15 squared times H. So dV dt is pi times 15 squared times dH dt. Let's see. So find dH dt. Oh, this is one of those algebra problems because I know dV dt is 4. Pi times 15 squared. I don't know dH dt, but I can solve for it. So that would be 4 over 225 pi. Answer choice C. So, again, you can plug constants in, but don't plug variables in until after you take a derivative. So number 17. A right circular inverted cone. Well, that's a mouthful. A right cone just means inverted means it looks like this. That's a right one. A not right one would be like if it's slanted like that. It's like that'd still be a cone, but that wouldn't be a right cone. It'd be a wrong cone, right? So a right circular inverted cone with height of 10 inches and radius of 2 inches is being filled with water. The radius of the water surface is increasing at a rate of 0.5 inches per second. So what is 0.5 inches per second in terms of variables? Braden, help us out. What is 0.5 inches per second? What variable is that? What letter are we going to attach to that? The radius of the water surface is increasing at a rate
How'd you say R?
You said R.
dr over dt.
I was right.
dr dt.
So how do you know when it's going to be dv or if it's dr?
Okay,
That's what I'm trying to
good question. How do I know if it's dr or dv? Which one is it? I would say there's two answers to that. One is the words, radius. The other is the units, inches. So inches can't be a volume. Determine the rate the volume of the water is changing. So we're going to find dv dt when r is 1.5. Volume is 1/3 pi r squared h. I would like to take a derivative to get dv dt, but let's do some things first if we can. R and h, as we add water to this cone, is R changing? Definitely, because it told us what R is doing. R is changing. R is getting bigger. Is H changing? If I add water to this cone, the H is changing. So I need to be careful. I can't plug in for H because H is changing. It also means if I take a derivative right now, what rule would I have to use? If I take a derivative of 1/3 pi r squared times H, I'd have to use the product rule. And dH dt would show up, and I don't even want dH dt. I don't know it. I don't want it. I have no information about H. So I'd really like H to go away because that is messing me up. It would be nice if I had some equation that I could, or some expression I could plug in for H. And that's why it told me the 2 and the 10. So how is H related to R?
Inversely. Wait, don't do that. Don't do that.
Let's see. If H is 5, R is 1. If H is 10, R is 2. Similar triangle type things. So I need an equation that tells me how H and R are related to each other. Well, if R is 2 and H is 10, so it's 1/5 or 5. I just need to be careful where I put the 5 or the 1/5. So 1/5 of H would get me R, and 5 times R would get me H. And the reason this is necessary is because now I can replace H with 5R. And I've got an equation now with only one variable in it. So taking a derivative is going to be a whole lot easier. dv dt 5 pi r squared dr dt. Let's see, we know dr dt, we know r, so we should be good here. 5 pi 1.5 squared times 0.5, and safe stop, leave it alone. Although I'm not quite done with this problem. What's left to do? Units. Indicate units of measure. Well, again, you don't have to keep up with the units. You can just grab them at the end. Radius is measured in inches, and time is measured in seconds for this problem. So there's my answer.